Hello, Kamil.
Hello, Wojtek.
I would like to talk today about selecting the right display for military devices.
Oh, fantastic. Super interesting topic.
Good to hear. So maybe you can start with importance of displays in military devices. What role do they play? Are they important or relevant?
So displays, of course, like in any industry right now, they are very important and relevant. Numbers of displays around us is growing, and they are actually helping a lot to feel us safer or just to be more informed and to control our environment, yes, with the displays. Because displays typically are not only the device that is showing you something, but also an input device. And in military, yes, they are very important, but require a special design. So there are many factors we should consider when we select the military display.
Mm-hmm. Right. Well, could you please give us some examples of such devices and how displays can enhance efficiency, operational efficiency, or safety in military equipment?
First of all, the military display, they need to be, we can imagine, very robust, like mechanically robust. We start with a little bit different approach of the housing design, backlight, and FPC. Everything that is connected need to be vibrant proof, etc. And of course the other parameters, because most of the military applications, they are happening outdoor, so we have a lot of sunlight or harsh environment, the temperatures, but also the altitude, which means the pressure. So we can work on the ground with regular pressure, but we can maybe be like 30,000 feet above the ground, so 10 kilometer, typically plane altitude, where there is a way lower pressure. And in some cases, for some of the devices, it may be an issue. So you need to consider that when you design.
It seems like pretty extreme conditions.
Yes,
for
they are
electronic devices.
Yeah, they are more extreme, of course. And like in aviation, in military, we have similar requirements. So very wide temperature range and super harsh environment.
And how about some examples like navigation systems, I guess? Maybe, I don't know, surveillance?
So in military, we have like two sets. So one is like in vehicle. So we have a display in a tank or like, a military vehicle in general inside. So it's a little bit different approach. And then we have equipment that the soldier is carrying with himself.
So handheld.
Yes,
mobile.
yes. Yeah. So in terms of in-vehicle display, we typically care about high contrast and then the robust design and then the touch working in this harsh environment. But when we have the handheld or like soldier carrying device, there is more even requirements than in vehicle, because additionally we have necessity to work with the thick gloves. Maybe if you are inside the vehicle, you can work with the gloves, but all of the actually military displays require working with the thick gloves. But in the outdoor, we also have often requirement on the low power, which is on the other side of the high brightness. So typically, if we want to have perfect readability, we put more brightness into the backlight. It's the same with our phones actually. Yes, we try to keep the battery alive as long as possible, but on the other side, we want the display to be highly readable, and we need high brightness. So for military devices that we already did designs with our customers, for handheld devices, we needed to take into consideration the power. If you are in the tank, the power doesn't matter. You have a lot of power actually, and the display is a tiny fraction of the total power of the vehicle. But if you have handheld device, the display may be the most current draining component in the device. So we typically do a lot of effort to squeeze the highest brightness with from the lowest possible power of the screen. There are some techniques also to increase and maybe use a reflected light, so we can prepare transflective display. Most of the TFT displays, they are transmissive. That means when there is no backlight, you cannot see them. The backlight is working in transmissive displays always against the environmental light. So if the sunlight is shining on the screen, we need a lot of backlight. But in transflective, we use a reflection. So the more sunlight, the more reflected light there is, and the brighter the display becomes. And we can even switch off in some cases the backlight,
which is power saving.
Yes, it's extending the battery a lot.
It seems like this kind of design is pretty tough and
yeah, it is.
And sort of minefield, so to speak.
Yeah.
You have to
Yeah,
be
exactly.
careful.
You need to know what you do.
Yeah.
Experience is necessary.
Speaking of tough decisions, what are military standards or regulations you have to cope with?
So basically, we work on two standards. So one is MIL standard 810, which is about environment around the device or display, and the second one is MIL standard 461, which is about electromagnetic interferences. Yeah, so these two documents are main requirements. They describe main requirements toward military devices and displays, of course, included.
Okay. Could you briefly tell us about the difference? You mean environmental and...
Environmental means like the temperature, vibration, more like a mechanical. And the second one, 461, is about electromagnetic interferences, so more like electronic. Like basically, we need to survive a lot of vibration tests and tests called, for example, helicopter drop.
Is it actually a helicopter drop?
Kind of, yes. In military applications, you assume that some of the packages may be dropped from like low altitude helicopters. So if you have no time, the helicopter may not, land, but it's like 1 meter above the ground. And to be fast, you just push out the goods, yes, into the boxes typically, but they are dropped to the ground. So you have you have the impact. You need to survive this. So the helicopter drop test. There, of course, we do not use helicopter to test it, but there are ways to test it in laboratory. Yes? So we have a special equipment.
Special throwing person?
Yes, no, not exactly, but we emit vibration and a drop test. Not a single component can be like turned off. Yes, so even from the PCB, etc. When you test it, you typically need to put the PCB downside and you put some, for example, glue tape under it, and then you drop it, and many times, and non-component can be dropped from the PC.
Yeah, because there is no time for service.
No time for service.
Yeah. Of course. So durability and reliability is pretty crucial. I guess.
They're super crucial.
Yeah.
One of the most important.
So we have discussed extreme conditions. We have discussed shock, vibration, some temperature variations.
Yes, temperature is typically wider. Maybe in industrial is enough. -20 to 70. In military applications, it's not necessary. It's necessary is more. So we need like -40, maybe up to 85. Why -40? Because if we have equipment that we leave outdoor and it's like a really, really cold place, then it will freeze totally, and we need to make it work in -40.
You mean operation of the device, or
yes.
-40 solo for the display?
I mean, for the entire device, yes.
Okay.
If we will switch it off and put it outdoor or in a tent or something like that, the temperature can drop that low and the device still need to work when we want it. So when we switch it on, so all the components actually in the military device typically require -40. Or in some cases, we can use a heat. So we use some heaters, and maybe like a couple of minutes, the device go from -40 to -30, and then it starts to work. Yes. So in some cases, it's allowed to use a heater.
And do you do the testings in-house, or it goes to the device manufacturer and he does the testing?
We do in-house testing of our components that are displays, so we can test everything around the display. We have our own chamber, so we can go to -40 or plus 100 degrees, etc., and test our displays. But later, of course, the customer, manufacturer, they also test it. So when they put everything together, they need to test again.
So it has to be tested many times
in
order to fulfill requirements. Okay, thank you.
Okay, thank you very much.